Hello all. Hello everybody. Today we are going to start linked lists using C programming. Linked list is a linear data structure where the access to the data that is stored is linear. That is, there is one entry point and you access all the data in the list in a linear order. Whereas the storage in the memory is absolutely random. Okay. The linked list actually looks like something like this. You will have a pointer called start pointer, which will contain address of linked list. Address of linked list. Okay. After that, you'll have the list, which looks like this. List of data items stored in something called nodes. Okay. This is the address of first node. Okay, which will be called start node. The start node have two parts. One is the link to the next data item, next node, say the node number 1, and then this contains data. Okay, then this also is the structure of same type, which contains pointer to next and some data. Again, this is node number 2, means structure number 2, which contains a pointer to next structure and its own data. Structure number 3, suppose this is the last structure. It contains pointer to next, which will be null, and it will contain its own data. Okay, this is how the linked list is created. These are all nodes, are actually structures. Linked list is a linear data structure, that is, it is accessed only in one way. Okay, linear data structure. Okay, access is from one point and in one direction only. Okay, so what happens is, in this linked list that you create, all the blocks that you see are actually structures, and you see every structure contains some data, and every structure also contains a pointer, which is a pointer to another structure. So this structure will look something like this in your code. Batch number is 153. Let me go to your batch number. Here we will do linked list, create a new directory for linked list. Here we are. We will open for a few tabs for linked lists here. Now, very first thing we do is let's create a declarations.h header file, and in this header file let's create a structure. Type def struct node. Okay, and this node will contain a pointer to itself. Struct node star next, that's what the name we have given, and it will contain some integer data also. It's a type def, we give it a name node, capital N. So this is how the structure will be created for linked list. The structure will contain a self-referential pointer and then a node. In this linked list, there will be some operations that we will be implementing. The first operation we will be implementing is create the linked list. Operations. on the linked list. First operation that we will create on the linked list is operations. Is create linked list. Then another operation is insert node. After the linked list is created, you can insert node. Another is delete node. And another is display linked list. Okay. Another is sort linked list in given order. Okay. And obviously exit. So these are the operations that we have to perform on the linked list. Okay. So I have not explained you the concept of linked list totally till now. I am just giving you one concept and implementing one concept and implementing. Wherever you feel that you're not able to understand any concept or any implementation, please ping me immediately. So the concept that we have created here is that there is something called a linked list which looks like this, and the operations that will be applied in the linked list are create the linked list, insert some new node, like this is a node, this is a node, this is a node. You can insert another node or delete some existing node or display the whole linked list or sort the linked list according to the data. One thing I would like to emphasize here is this: the start node will not contain any data. Data will be there from the first node onwards. Okay, always. So let's jump to program and little bit things that we know. Let's do. Hash include stdio.h, std lib.h. Well, these two we know till now. Let's see what else will be there. We'll see as and when. So this is the declaration.h. Okay, let's go to main. In the main function, we'll start our linked list program. Hash include headers.h and declarations.h. Both the header files included. Now we start our main function, int main function. In this main function, as usual, give the function begin end statement so that we know where are we in our control, where is the control in our program. So the function name begin, and the function name will be printed using this macro, and function name end. In here we have to run an infinite while loop in which we will call main menu function. Okay, main menu function has to be declared in the declarations.h. the generic function void star main menu void star. Then we'll have exit function. These two functions will start with. Okay, main menu is here. We'll have to call the main menu. In the initialization function, we have to create the main menu first. Initialization function. Well, these functions has to be declared as external. And then we have to have an array of function pointers also. Void star array of function pointers. Star fptr size is number of functions. Arguments are void star as usual. So this macro we have to define here. Hash, if not define number of functions, then hash define number of functions is right not true. hash intf. Done. Okay. So in the initialization function, we have to initialize it. Initialization function, where before we do this, we have to declare both the functions in the global space in the initialization function. Here it is, declared. Now we have to initialize both the functions in the init function. So fptr 0 is going to be your main menu, then fptr 1 is going to be your exit function. That's it for now. Okay, and we are in main. Here we'll call the main menu function. The main menu function is star fptr 0, and the argument will be this extern has to be removed from here. That's right. And the arguments will be, when you call the main menu, this, the start pointer. The start pointer is node start pointer. Before you get into the loop, you would have called the init function. Okay, and you would have made start is equal to null. So initially your start pointer is null. That means there is no linked list. Okay. So now the main menu function is called, and the start is passed as argument, which is a node pointer. Typecast it to void pointer. It will return the void pointer start. We'll see what it will return. Let's go to main menu function. Main menu dot c. In the main menu function, we take a void argument, and then in the main menu we have to display the main menu. There it is. Choices. Number 1 is create linked list. Well. We won't display the create linked list as such. We will see. We'll take a node pointer. Okay. And then we will initialize this node pointer, typecast it to node star, take it from arg, and see if not strt, means if it is a null, then only you display the create linked list, otherwise not. Else you will display rest of the menu. If the linked list is not null, start pointer is not null, that means the linked list exists. Then we give the command to insert node 3, delete node 4, display linked list 0, exit program. Then you say, please enter your choice. Please enter your choice, and you will enter choice as an integer. Say I is the choice. Declare I as an integer. I hope everybody is able to understand, else you ask me question immediately. Now I is an integer. Now I'll make a function call. First we have to make a separate call for exit. If I is equal to 0, then you will make a function call for exit. Function pointer is exit. So if the value of I is 0, that means you're going to exit the program, so you have to call the exit function. And you see in the initialization function, the exit function is function number 1. So we have to call the function number 1 here. Star fptr function number 1. Okay. And the argument that will be supplied from here is a string that is success. This is a character pointer. You typecast it to void pointer. Okay. This is done. Now, else if the value of I is greater than 0, and let's make it greater than equal to 1, and the value of I is less than equal to 4, then it will be a valid choice. In that case, you will make the appropriate function call, which will be insert create linked list, or insert node, or delete node, or display, whatever. So instead of passing 1, which is I here, this will become I plus 1, and this will become I. Suppose you create linked list, so we have to create the functions create linked list. So let's create these functions as well. Create linked list, insert, delete, display. Yes, this will also be external. Now exit function, then we have create linked list. Then we have insert node. Then we'll have delete node. Then we'll have display linked list. These functions. All the 4 functions are external, so these functions have to be declared in the initialization function. Like this. These are function declarations. After the functions are declared, then you have to have the function pointers for these function declarations. Number 2 will be your create linked list. Then this is number 2, no? 3, 4, 5. Number 5 will be your display linked list. In between, number 3 will be your insert node. And number 4 will be your delete node. Okay. So these are the excuse me, these are the functions we got. Okay. And from the main menu function, we will call the appropriate function here. This is the call to the exit function, and this is the call to all functions. Okay, here I plus 1 is 0 plus 1 makes it 1. If you see, function number 1 is exit function. So we are going to call these functions, and these functions will not take success. Instead, these functions will take the start pointer as argument, which is arg itself. Arg, which was a anyway the void pointer, and it is not null, so it is being passed. The start is passed as argument, and you don't have to do anything else in the main menu as of now. So let's move here and let's have the exit function. We wrote the exit function in declarations in MDC project, so we copied here. So this is our exit function, in which we check that if it is 0 or 1, a success or failure, and appropriate exiting happens. Now we need create linked list function first. .c. In the create linked list function, it's a generic function. Word star create linked list argument is also word star arg, which is the start pointer, will come as argument. We won't do anything as of now in this. We'll just map the functions and leave it as it is. The return value will be not null but arg, because we are capturing the return value. So this was create linked list. Copy the create linked list to display linklist.c to insert node.c to delete node.c change the function names. Insert node, delete node, and then display linked lists. That's it. All the functions has been written. Now we have to write a make file for this. Hash bang bin bash is the shell that we are going to use. We are going to create linked list, which will be created from main.o, init.o, main menu.o, exit function.o, create linked list.o, insert node.o, delete node.o, and display linklist.o, and these will be applied with a rule through GCC. Optional name will be given like this. Okay, now all these dependency will resolve like this. Main.o will be created from main.c, headers.h, declarations.h, and then you compile only main.c. That's it. Then you'll have main menu. Then you'll have init. Then you'll have create linked list. Then you'll have display linked list. Then you'll have insert node. Insert node. And then you'll have delete node. That's it. Let's see that all the files are saved. Save all the files. And run. Make. Declarations.h needed by main.o. Oh. Yes. Declarations. Make. Build is failed. Implicit declaration of function init. I did not declare init prototype. This is init function. In declarations, where is the declarations.h? Okay, it is s declarations.h. We need to declare init also. Init function. Okay, let's do it. Make says inti.c. Oh, file name is wrong, I think. No, it's okay. So maybe the fault is in Makefile. Here, init. Done. Make. Now it says there are some more bugs like conflicting types of main menu. So in declarations.h, I have said that the main menu will be void, and then when I use main menu, return type is integer. So this return type won't be integer. This will be void star, as we have taken all generic functions. Make again. Now it says that unknown type noid, where main menu line number 7. Funny. This is node. Node. Test again. Make. Header.h. It is headers.h. Exit function.c, which we copied from somewhere else. Exit function.c. This is headers. DER. Yes. exit.h. Okay, make declaration.h in exit function. Okay, that also has to be corrected. It is not declaration.h, it's declarations.h. Yes. Make compilation to exit function. It is declarations function spelling. LER declarations. DECLE. Make is successful? No, it's not. It's an undefined reference to FPTR. In function init, undefined reference to FPTR. Init function is not working properly. Headers.h, undefined reference to FPTR. Why so? FPTR. Yeah, we did call init. In function main, undefined reference to FPTR. So this is the declaration function in which I have declared all the generic functions as external. Then in the initialization function, I included the declarations.h header file, declerations, declerations.h. Okay, so all the files are included. Oh, I did not declare this array. We missed it here. Now it would be fine. Make. There it is. Undefined reference to exit function init.c. Exit function is okay. Here also exit function is okay. Here also exit function is okay. Now you go inside exit function. Like this exit f is going to be exit func, and then we have to must write this unless you're learning. %s begin, and this is from function, and this is the end statement. Done. Let's try once again. Make is not successful. Implicit declaration of strncmp. Well, we need the header file for this. Headers.h. For strncmp, we need string.h. Hold on. I think this is the one I am waiting for. Hello? Wait. String.h. Included and test once again. Now this time, oh, we are able to build it properly and the linked list is created. So ll run. Oh, we are into infinite while loop. Okay, we did not ask for choice. Stop. There is some problem in the main menu. There is a scanf here in the main menu. Please enter your scanf %dfni. Why didn't it just stop at scanf? So what is happening is main menu, create linked list, main menu, create. It is always executing in main menu. It is never going back to main. Main menu, create, begin. This is one execution of the complete main menu function. So it is printing create linked list all the time and going out. Going out. Okay, yeah, that's the issue. Because it is going out from here, we never did this. Please enter your choice. We never did because it was in the else part. Yeah, this particular statement, the scanf statement, should be out of else part because it was never going to else part, it was never doing scanf. So make again, run again, there it is. One for create linked list. Okay. Oh, segmentation fault. Exit function begin. Please enter choice. I gave 1 and then it was segmentation fault. So in main menu I gave 1. So I was not 0, it was 1. So I was greater than or equal to 1, yes. Less than or equal to 4, yes. So it called function number 1. And the function number 1 was exit function. So this should have been 1 plus 1. Create linked list. Create linked list is function number 2. So it should have been 1 plus 1. Now it's fine. Let's try once again. But still it shouldn't have been segmentation fault. So there is exit function segmentation fault. We got a segmentation fault from inside exit function. Why so? Exit function. We called exit function from main menu. Okay, this is here, and we are passing success as an argument. So success is captured as an argument arg. This is arg compared with capital S. It will be small s and small failure. Okay, so the comparison will happen, and you exit success or you exit failure. That's okay now. Let's try once again. Make run one create linked list. Create linked list begin end. That is good, isn't it? Please enter your choice. The moment I enter 0, it goes. So architecture is complete. In create linked list, what we have to do is, in the create linked list function, we have to allocate space for this node, struct node, and store the address in the start pointer and return it. That's it. So to do that, what do we do is we write a new function that will do create node, because a create node will be done again and again and again. So therefore we will write the function for creating node. Create node. So we have 1, 2, 3, 4, 5, 6, 7 function. Yeah, same size. So the number of functions is 7. Okay. So create node has to be declared in the initialization function, and inside, and the create node function pointer should be initialized, which is in the array. Create node fptr6 is equal to create node. So this is the function. When the create linked list function will be called, this create linked list function will first check arg. Is it null? Well, the create linked list function will be called only, arg has to be checked anyway. If arg means arg is existing, it is there, it's a valid pointer. So in that case, you have to wait. Let's create node star strt. Strt is equal to typecast node star arg. Now you have this, and check if strt, it's a valid pointer. That means you can't create linked list, you already have it. You have the linked list already created. Okay, and then you return arg, which was the start pointer. Okay. Otherwise, if it is null, then you will reach here and you will call create linked list, create node star fptr function number 6 will be created with you don't need any arguments till you pass arg. Okay, so it will create the new node, and the new node will be your start node, which will be stored in start this, and it will be returned. It is a node pointer. You typecast it into void pointer and return. Oh no. Yeah, return it. Fine. strt. Okay. Now let's go to create node. Inside create node, it's very easy. We'll just have to allocate space. That's it. Create node. Okay, you just have to allocate space. Malloc. Node star. Malloc. How much space? Size of node. Memory is allocated. Typecast it to node pointer and store it in the node pointer. Let's call this node pointer as new. And if in case there is some bug, you will report malloc failed. Now inside this node that you have created, there are two elements. One is the next pointer, this, and one is the data. So next pointer is essential for you to make it null initially in the create node function. Okay. So this is new actually. No, this won't be here. So now what you'll do is new points to next is equal to null. Tell me if you are able to understand this. Why did we do null? Because whenever the new node is created, it is the new node and the first node, and there are no other nodes. So therefore the next pointer will be not be pointing to another structure because it doesn't exist. Instead this will be null. Okay. And you'll return new. The new that is returned, which is pointed to the new node, is returned as void pointer will be captured in strt. Isn't it? Why don't we capture it in arg only? Void pointer captured in arg and returned as a void pointer. That's it. Create linked list. Done. Let's see if it works. In which function? Fixed. So let's see if it works. Okay. Yeah, this will be FPTR. We'll need to open the Makefile. We have a new function called create node. .o. create node. Yeah, sorry. Yes, we will, and we can do, and we will do. Make. So in create linked list line number 14 there is some issue. Semicolon missing. Build successful. Run. Successful. 1 for create linked list. Oh, it should have shown you the rest of the menu. Chalo, there is some bug. We can't see that. Okay. So I'm out of time. So tomorrow we'll continue it further, and I'll give you the concepts. Right now I'm not giving the concepts. See, I've not done any work. I've only created function pointers and containers and make things ready. All the function where the actual concept of linked list comes into play is not yet started, isn't it? And whatever little we try to start, there is a bug in that. So we'll resolve it tomorrow and proceed further. I hope you are able to understand this. Okay. So that's all I got for you today, and I'll catch you people again tomorrow in the next session, where we'll move ahead and implement linked lists.